Today we're doing the 2018 maths paper 1. It's been a minute since we covered maths. We've just been covering combined science. Today we're changing that. We're going back to maths. Okay, this is November 2018. So the first question says simplify 2 to the power 3 divided by 5 to the power 2. Give your answer as a fraction. Okay, simplify this, giving your answer as a fraction. So 2 to the power 3 divided by 5 to the power 2 equals to 2 to the power 3 simply means 2 by 2 by 2. Okay, so 5 to the power 2 means 5 by 5. Normally these questions, what you realize is they'll be having 1 mark. Okay, so if you're really quick, then you can just compute the answer if you're confident. 2 to the power 3, it's simply 8. But if it confuses you, just say 2 by 2, then you get 4 by 2, then you get 8. 8 divided by what? By 5 to the power 2, which is 25. Okay, so if you're really good at maths, don't include the stage because it's just 1 mark anyway. They're going to give you the mark only for the answer. Okay, so you get this one. Then the B part says part 1 says 6 divided by 25 as a decimal fraction. So express 6 divided by 25 as a decimal fraction. I'll use 2 methods for this. Most of you will use this one. I think it's a bit more complicated, but then it's a method that you can apply to any question really that involves conversion of a fraction to a decimal fraction. So you say 25 into 25, you get 1. Into 6, you get 0. Remainder 6. Then you add a 0. Into 60, you get 25 into 60, you get 2, as in up to 50. And then you're left with the remainder 10. Then you add another 0. 25 into 100, you get 4. Okay, so this would be your answer. If you're really good at maths, this is the alternative. If you're really good at maths, this is how you could compute the answer faster. So it's 6 divided by 25. You multiply this by 4 by 4. 4 by 4, this one, it's simply 1, okay? So we're not changing anything. The reason we're multiplying by 4 by 4 is so that we can have a power of 10 here. So what you realize is that you have 6 by 4, you have 24 divided by 100, of which 24 divided by 100, you guessed it, it's 0.24. Okay, so this is another way to compute the exact same thing, but then I advise you just know both. But then whenever you have, let's say 10 here, just multiply. Let's say you have 4 here, you want to change to a fraction, you can even multiply that by 25. You have, let's say 50 here, you want to so maybe 6 divided by 50, just multiply by 2 so that you get a denominator that you can easily convert for the fraction into a decimal fraction. Okay, so it's simply 0.24. So this one says express in standard form. So express this one in standard form. So just to recap, standard form is this form: a divided by 10 to the power n, where a, it's a number. This number is greater than 1, but then it should be less than 10. Okay, so it can be 1 point something, it can be 1, it can be 1 point something, but then it cannot be 10, it can be slightly less, it can be 9.99999, that's acceptable, but then it's never 10. Okay, so n is an integer. So this is how we write in set notation. Okay, it simply means n is an element of integers. Integers, we denote them by this z here, and when we're writing z, we put this cross so that it's different than 2, especially for us with bad handwritings. So you'd get 0.125. So what you do is you first identify the first significant figure. The first significant figure always is the first non-zero digit. So as this 0 here, it's not significant. We keep on going to the right until we get the first non-zero digit. So the first non-zero digit, it's 1. So our comma is supposed to shift up to here. Okay, up to the first significant figure. So you'd actually get 1.25. What you notice now is that 0.125, it's smaller than 1.25. So you've made your number, you've made it bigger than it was initially. So if you make a number bigger than it was initially, you give a negative power here. So negative what? Negative the number of times that you shifted the comma. So in this case, it's 1. Okay, like this. And then if this still confuses you, what you do is when you move the comma to the right, always it should be negative here. When you move the comma to the left, let's say it was 125. Just an illustration here. Let's say it was 125. The comma would be here. Okay, so you'd have to move the comma to the left. So it'd be 1.25 here. So you'd have to multiply by a positive power. If you move to the left, you have to multiply by a positive power. But the best way to go about it, especially if you're fast with math, is 125 is big, 1.25 it's small. I have made my number small, so I have to power it. I have to empower it to the power to the number of shifts that I made here. So I have to power it. It means it has to be a positive power. Here we made it bigger, so we have to. The concept of scientific notation is that you're not supposed to change the value of that number. That's why when we make this bigger, we have to multiply it by a negative index of 10. Here we have made this one smaller, so we have to multiply it by a positive index of 10. It means we're empowering it. Let's quickly move to the question 2. So question 2 says the following is a list of real numbers. Choose from the list a square number. Okay, choose from the list a square number. A square number simply means a number that has a perfect square root. Okay, so 3 over 7 obviously doesn't have a perfect square root. Same with 11. The same with the square root of 2 over 3. Same with the 121. 121 actually has. Okay, so 121 is what we choose here. So choose from the list a square number. It'd be 121. A square number simply means a number with a perfect square root. So negative 19, obviously no. Pi, obviously no. Square root of 64 here, you get what? Square root of 64, you get 8. 8 by 8, you get 64. 8 doesn't have a, a square root. That's why we say 8 isn't a square number. What they did here was they wanted to confuse you. This number, if you read it as square root of 64, it can be a bit tricky to tell if it's a square number or not. Okay, so what you do is just write the equivalent. What's the equivalent? The equivalent is 8. Now you judge 8. Is 8 a square number? Obviously not. Then you decide against it. Okay, so here either this one, it's a square. It's a square of what? Of 11. 11 squared, you get 121. Okay, and the other thing that you should know is you are expected to know all squares for numbers. What? You're expected to know all squares for numbers 1 to 13. Okay, so you should know what's 1 squared, what's 7 squared, what's 13 squared. You're expected to know from memory. It'd be easier for you that way. Know up to 13. And for everything else, you just use SEDS. There's some topic that you do. It's called SEDS. It will help you ascertain if big numbers, they're perfect squares or not. Okay, but then for our case, fortunately, we didn't have to do that. So the answer would be just simply 121. Irrational numbers. Now, irrational numbers, what are they? They are numbers which cannot be expressed as ordinary fractions. Okay, numbers which cannot be expressed as ordinary fractions. Let me actually write here. Be expressed as ordinary fractions. Ordinary fraction simply means you have a numerator, you have a denominator, and these two, they are real numbers. And then obviously that's an ordinary fraction. Okay, so if you have a and b, they're real numbers. It means real numbers. It simply means positive or negative numbers. It can be a decimal, no problem. As long as it's real, it means it's a number that you can tell on a number line rather. Okay, So 3 over 7, 3 is a real number, 7 is a real number. Obviously, that's a rational number. Rational. Okay, it's something that we can express as an ordinary fraction. This one, it's 11, 11 over 1, that's rational. This one now, we cannot, this one would be square root of 2 divided by square root of 3 divided by square root of 2. Let me just illustrate here real quick. So 3 over 2 is equal to square root of 3 over square root of what? Of 2. Square root of 3 doesn't have a perfect square root. It's 2, say same with 2, okay? So this one we say it's irrational. So we are going to choose square root of 3 over 2. And then you put your semicolon here. It's very good when you're separating numbers so that it's different than the comma. Okay, presentation is it's key as well when you're doing your math. So 121, it's 121 over 1, rational. Negative 19, negative 19 over 1, rational. Pi is irrational. Okay, pi it's irrational means we cannot express this 21 over is it 22 over 7, the approximation that we use. This one, it's an approximation. Okay, it's not the exact value of pi. We actually use it as an approximation. It means that's not the exact value. Pi itself, it's irrational. It just keeps on going, and you cannot express it in terms of a definite ratio of real numbers. So pi, if you didn't know, pi, one way to just it an aside, pi d, you get the circumference. Okay, so pi is the ratio of the circumference to the diameter. So the ratio of the circumference to the diameter for any circle that you can think of, it's exact, and it's what? It's pi. Okay, that's what we call pi. It's exact in the sense that it's the same for all circles that you can think of. For smaller circles, your approximation would be less, but then if you write for big circles, you keep on getting the value of pi, the accuracy keeps on getting higher and higher and higher, and the precision as well. So that's it. So these are the two irrational numbers, because this one we say that it just gives 8. So the two irrational numbers would be 3 over 2 and pi, which makes sense anyway because they just gave you 2 marks here. Let's quickly move to question 3. Let's do question 3. So question 3 says 4 by 5 to the power, express 4 by 5 to the power 3 plus 3 times 5 to the power 2 plus 2 as a number in base 5. So what you realize is you only have 1 mark here. So usually when you're given 1 mark, it simply means the answer, it's either immediate, you can just work it out in one step, or the answer it's something that you can recall from memory. Okay, usually it simply means that your question, sometimes if you're not sure, just look at the marks. The marks, they tell you how much work you're supposed to put in. If this were a difficult question, you'd be having maybe 3 marks here. There's a reason you have only 1 mark. Okay, you start from a place of familiarity. Why is it they gave us in this format here? So that inquisitive spirit, it can help you throughout your studies. So let's say you have this one here. If you're asked to convert it to base 10, what you realize is that you take number times base to the power, right? And then you say plus number times base to the power. Then you say number 3 times base to the power. Okay, so this is the same format that you're given here, but then the only difference is that this format here, it's missing some elements. Okay, so you realize that this we have 5 to the power 3, 5 to the power 2, 5 to the power 1, and 5 to the power 0, but then there are some missing elements here. Okay, so we actually have this one, we have this one, we have, but then we don't have the 5 to the power 1 1, and we don't have the 5 to the power 0 1. So readjust. Where we don't have it simply means that it's 0 there. Someone was simplifying that stuff for us. So here 3 by 5 to the power 2 plus, there is no 5 to the power 1, so it's 0 by 5 to the power 1. Okay, plus 2, this 2 here, it simply means it's 2 by 5 to the power 0. Okay, and if you are given this now, you can reverse your reverse engineering. It means you're going in the other direction. So now you can check the numbers. Okay, so it would be 4302 to the board, to base what? To base 5. Okay, 4302 to base 5. So if you didn't know this method, what you'd have done is 4 by this one would be 125. Okay, 5 to the power 3, it's simply 125 plus 3 by this one would be 25. Then plus what? Plus 2. Then here you would have 125 by 2, you get 250. 250 by 2 again, you get 500. Okay, so you get 500 here. Here you get 75 plus 2, 77 here. So you get 577 like this. This one would be in base 10. Okay, and you would have again to take the extra step to convert this to base 5. So you do the t thing, and or this one usually use it when we are finding factors. We also use it in prime numbers as well. So here you insert 5, you divide by 5 repeatedly, noting down the remainder. So it'd be 5 into 5, you get 1. 5 into 7, you get 1, remainder 2. 5 into 27, you get 5, remainder what? Remainder 2, like this. Then 5 into 10, you get 2. Then 5, remainder 1. Then 5 into 15, you get 3, remainder what? Remainder 0. Then 5 into 23, you get 4, remainder what? Remainder 0. Remainder 3. Because 5 into 23, it's up to 20, and then we're left with 3. Then 5 into 4, it's 0, remainder what? Remainder 4. So you would read going from bottoms up, so you'd still get the 4302 base 5. You see, yeah. The problem now is that this method, the second method, it takes long. Okay, so that's why constantly you just look for shortcuts as much as you can. Maths, it's not only about knowing, it's also about having tactic. Okay, be tactful. So here it was 1 mark. You didn't have to go through the whole process here like this, because it's time consuming. It means that sometimes you won't finish your exam. Okay, so check the first method, it's good, and then evaluate this, giving your answer in base 2. Okay, so we have 1 0 1 1 1 base 2 plus 1 0 1 0 base 2, like this. Okay, so we're adding. So if we're adding, it's we're adding base 2. Okay, when you're adding base 2, the clue is our numbers, they're all ones and zeros. If you find yourself writing 2s there or any number, then it's wrong, it's incorrect. Okay, if you're in base 5, for example, you see these numbers, all of them, you never find 5 and going upwards. You never find the base for the number that you're investigating. Okay, you never find the base in the number for this. So the base is 5, you never find 5. If the base is 6, then the numbers are 5 going down below. I've said it before. So here, 1 plus 0, you get, simply get 1. 1 is permitted, you can write. So here, 1 plus 1, you get what? You get 2. But then if it's 2, you are in base 2. It simply means you carry the set. So 2 is equal to one set of 2. Okay, plus 0 remainder. Okay, so here we leave the remainder and then we carry the set. Carrying one set here. So here again you get 2, so it's 1 set of 2, remainder 0. So we leave the remainder, we carry the set. Okay, here also same thing, we leave the remainder, we carry the set. Here also same thing, we leave the remainder, we carry the set. So it'd be 1 0 0 0 0 1 base 2. Okay, now if you're having a hard time understanding why this is done, I will give you a very simple illustration here. So let's say plus 44. No, let's put 7 here. Okay, so if you're adding primary school stuff, so if you're adding from primary school, what you'd do, you'd say 7 plus 4, then you get what? 11. And then you'd say you leave one remainder, then you carry one set here. This set that you're carrying here it's you're carrying 10 just because we are in base 10. Okay, so you carry the sets of 10. That's what you'll be doing, but then they just don't tell you. So here also it's 5 plus 7, then you get what? You get 12, and then 12 you leave remainder 2, then you carry one set of 10. This is what will be happening. So now you're in base 2. It simply means k sets of 2. Okay, so for example, 1 plus 1, you get 2. You are in base 2. How many sets of 2 twos do you have? You have one set. This is what you're supposed to carry, and then you're left with what remainder? It's 0. Then you carry that. Okay, let me do another quick example, but this is what you get essentially, and then just count the zeros. The zeros are 4, so we're good to go. So let me just say 45 per 6 plus let's say 52 per 6. Okay, let's add this one and then see if you got the concept. If you can, just pause the video, just do it on your own, and then you see the answer as I explain further. Okay, so you have 5 plus 2, then you get 7. 7 means one set of this base that you're dealing with. One set of 6 plus what? Remainder what? Remainder 1. Okay, you have one set of 6, then you're left with the remainder 1. So this remainder is what we write, the set we carry. So here again you have 10. 10 simply means what? One set of what? Of 6 plus remainder what? Remainder 4. Like this. Okay. So you write the remainder, you carry the set. Then set, obviously, you get 1. So this is how you're supposed to, imagine doing this. So if you know how to add numbers in base 10, those ordinary additions from primary school, then you should know how to add numbers in any base, because the concept is the same. Just be mindful of what are the number of sets that you have, and what are the remainders that you have. Leave the remainder, carry the set. Always done. And then this one says evaluate this, giving your answer in base 7. Okay, so you want to evaluate this, giving your answer in base 7. Again, I will do this, and then I'll tell you why this should be this maths of number bases, why they should be simple to you. So here, let me actually use some space. Okay, so let's go here. So it's 5, 12, base 7. Not divided. What am I doing here? So minus 4, 3, 5 base 7, like this. Okay. So here 2 minus 7, it can't. Okay, we say it can't, and if you studied your primary education in Zimbabwe, then we say it can't. And what do? We okay. Let me illustrate first. If we were doing it in base 10, okay, ordinary stuff. What we are doing there in primary school, that's what we want to investigate. Why were we doing what we were doing? So here we'd say 0 minus 7, then we'd say it can't, and then what would we do? Would add 1 here, and then here this one would read it as 10. Why were we reading this as 10? This one was base 10, by the way. We just never told. Why were we reading this as 10? What was happening? What was happening was that you were adding 10 here. Why were you adding 10? Because you're dealing with the base 10 here. If this had been 1, right, and then let's say this one wasn't there, you're adding 10 here so that it becomes 11. But then it was so convenient to just write this so that you can read it as 11. Okay, but then essentially you're adding the set, you're adding the value of the set there. So here also the same thing. It can't, so what do? Add one set here. One set is equivalent of 7 units. Okay, so you're adding 7 here, you get 9. Here you increment by 1. It's almost the same thing here. It's always the same thing here. Here would get 11, and then you'd increment this one by 1, so that there's some balance. Okay, so here you'd get you'd put one set of what? Of the base, one set of 7. That means that you're saying 2 plus 7, then you get 9 here. Then 9 minus 5, obviously it's 4, right? So let me rub this part here. So 9 minus 5, you get 4. So here 0 minus 4, You can't do it again. What you do is you add one set of what? Of 7. So this actually becomes 8 because you have 7 plus 1, 8. Then increment this one by 1 as well. So this one becomes 5. So 8 minus 4, you get what? You get 4. And this is it. So your answer is supposed to be 44 base 7, like this. Okay. Let's see if you understood. The base, you're supposed to add sets just like what we were doing when we were comparing with what we used to do in primary school. Okay, you add one set here, we're adding 10, that's why we're reading this as 12. But then right now we're in base 7, if whatever base we are in, if we're in base 6, add 6 units here, and then add 1. If you add 1 and 6 units here, it's the same, there's balance. We're not changing anything, we're just making it convenient for us to do our operation. So here you simply get 44 base 7. Let's quickly move to question 4. Question 3 says express 0045 in 12-hour notation. Okay, 0045. So 0045, it's 12:45. But with the 12-hour notation, you have to clarify, is it PM or is it AM? Okay, 00, it means the day is just starting. So the day starts in the morning, okay, midnight. So it'd be AM. So that's it. Gotha's local time is 3 hours 45 minutes ahead of our local time. Find the time in Harare when the time in Gotha is 21:23. Okay, so this is 24-hour notation. So Gotha's time is 3 hours 45 minutes ahead of Harare local time. Okay, so Gotha's time is ahead. So if you want to find Harare local time from Gotha's time, you have to subtract 3 hours 45 minutes. Okay, so what you're subtracting 21, 23, which is the time. So here you can write this ones will be hours and this ones will be minutes. Okay, so you're subtracting 3 hours 45 minutes. Okay, and yeah, so for the minutes, what we have here is we're working in base 60. Okay, as in 60 minutes make up one set there. So for us to subtract 23 minus 45, it can't, so we have to add 60 here, as in 60 minutes, and then 60 plus 23, you actually get 83 here, and then we have to add 1 hour here, so this one will be 4. Okay, so you have 83 minus 45. So 83 minus 45, what do you get? So 83 minus 45, 13 minus 5, you get 8 here, I think. Yeah, you get 8, and then you get 5, and then you get 38. Okay, so 83 minus 45, you get 38. Done. And then 21 minus 4, what do you get? You get 17. So the time in Harare would be 17:38. Okay, it would be 17:38. Harare is behind, so Kotha's time is ahead of Harare's time. So Harare is behind, and the time would be 17:38. So here, this one will be working with base 60, as in 1 hour. So yeah, that's why we added 60. And then the conversion for square kilometers to hectares, you should commit this to memory. Okay, 1 square kilometer is to 100 hectares. Okay, so 1 square kilometer is to 100 hectares. 5 square kilometers is to what? It's to more simple proportion. If it's small, that means a bigger number at the top and smaller number at the bottom. Okay, so by 100 hectares, so 100h here, so cancel, then you get 500 what? Hectares. Okay, so 500 hectares, that's what we get. Let's quickly move to question 5. Express this in ordinary form. So express 6.07 in ordinary form. So times 10 to the power 4 simply means times 1, 1, 2, 3. So times 10,000. Okay, so what you do here is just write your number first. So comma 07. You can add zeros here because zeros after the comma, they don't change the value of the number. And 10,000 means we have to shift the comma 4 times the number of zeros. Okay, so 1, 2, 3, 4 times here. So you get 60,700. Okay, this is ordinary form. This is scientific form or scientific notation. Then that's it, you're done. So evaluate this times 10 to the power 1 plus this times 10 to the power minus 1, giving your answer in standard form. Okay, so we have 2.53 times 10 to the power 1 plus 6.1 times 10 to the power negative 1. Your answer should be in standard form. So there are two ways to go about it. I will show you both. So for this one, what we do is we can match the, sometimes this method that I'm telling you, it's useful, but then here to compute the answer probably the slowest. Okay, so 6.1 times 10 to the power negative 1 here. You want to create times 10 to the power 1 here. So if you want to create this, you have to multiply by 10 to the power negative 1 again, so that it'd be this one and this one cancelling. Okay, we didn't change even a single value there. What we just want is a scenario where this number is the same. So here you'd get 2.53 plus here you'd get 0.0, because you're multiplying by 10 to the power negative 2. Okay, so it'd be 0. Your 0.061 like this, then times 10 to the power 1. So let me actually like not skip steps here so that you understand better. So it's 2.53 times 10 to the power 1 plus 6.1 times 10 to the power negative 2 times 10 to the power 1 like this. So here you get 2.53 times 10 to the power 1 plus this one, now you get 0.061. okay, you're simply, you have 6.1 and then you're simply moving the comma. Since it's negative, you're simply moving the comma to the left 2 times, so you get 0.61 like this times 10 to the power 1. So obviously you have to, you can figure out what's common, and then you get 2.53 plus 0.61. So here you get 0.061. okay, so you get 2.591 times 10 to the power 1 like this. So you get 2.591 times 10 to the power 1 like this. So this is how you would do it. Let me write 2.591 times 10 to the power 1 like this. This would be the answer. Okay, so another way to go about it would be to, so here you're matching the powers, and then we took the higher power. That's what you take there. So that's what we did. And so now let's see, let's apply a different method. The different method would be to actually evaluate. So this one would be 25.3 here. Okay, because you're multiplying by 10. Here this one you're dividing by 10, so it'd be 0.61 like this. Okay, then you have to add. When you add, you get 25.91 like this. Okay, so in order for you to adjust now, the adjustment would be 2.591 times 10 to the power something. Okay, you have shifted the comma to the left, or this number, it's smaller now than what it was, so we have to power it by the number of shifts in the comma, so the shift would be 1 here, so that's why it'd be like this. This one was simpler for this question only, but usually the other method that I showed you, it sometimes computes the answer the fastest. Okay, so just learn both if you can, but if you can't, learn the first one. The first one was really good. and it's also universally applicable. So that's it for questions 1 to 5. We'll continue from questions 6 to 10 in the next part. Yuba out.